Hey guys, today we're going to learn how to do logarithmic differentiation. So we use logarithmic differentiation when we have complex problems like this, where the product rule, chain rule, or quotient rules won't really help us out. The steps we need to take in logarithmic differentiation are first, taking the natural log of all the terms. Second, taking the derivative of the entire problem statement, y equals f of x. And third, remembering to plug y back in, given in the problem statement, which you'll see what I mean in a second. Jumping right in, let's first take the natural log of every term given in the problem statement so that we could then take the derivative of the whole thing. Starting on the left side, we have the derivative of ln y, which is just 1 over y, dy dx. And then on the right side, we see now the beauty of logarithmic differentiation is we remember the general rule that ln of a to the power of b just equals b ln a. So logarithmic differentiation is a way for us to get something complicated like this term and turn it into something more simple like x cubed ln of x, which we can easily take the derivative of. So I'll rewrite that below. We're taking the derivative of x cubed ln x, which is just the converted, simpler version of this term. We notice right away that this derivative is multiplying two terms together, so we'll just do the product rule over on the side. If you need a simpler product rule example, please refer back to this video in the playlist. But we can jump right in with this and define u as x cubed, v as ln of x, then du dx equals 3x squared, and then dv dx equals 1 over x. And the product rule goes as follows. It's v times du dx, which is 3x squared ln x, plus u times dv dx, which is going to be x cubed over x, also known as x squared. So let's plug that into our equation over here. We have 1 over y times dy dx is equal to 3x squared ln x plus x squared. So now if we want to isolate this dy dx, all we have to do is multiply the entire problem statement by y, which leaves us with dy dx equals 3x squared ln x plus x squared, all multiplied by y. So what I was talking about in the beginning here, we need to make sure we plug y back in. How logarithmic differentiation works is this y can't stay as a term. It actually is represented here by the problem statement x to the power of x cubed. So we can't have our final answer until we plug y back in. So our final answer comes out to 3x squared ln x plus x squared, all multiplied by the original problem statement given, which is x to the power of x cubed. So again, just to reiterate, the entire reason we do logarithmic differentiation is so we can utilize the logarithmic simplification rules like this one to simplify our problem statements and more easily get the derivatives of them. So that's it for this video. If you just remember those 3 steps we went over, I'm sure you'll have no problem with the log differentiation problems on your exam. Good luck, everybody, and I'll see you in the next one.